Hello students, welcome to EPG Parsala. In this session, we shall discuss the topic Introduction to Atmosphere, Space and Universe. If a curious mind looks at the star-studded night sky, many questions will surely haunt him. What could be the total number of bright point-like entities? How big are they? What material they are made up of? Whether they experience the same weather like we get in the earth? How one shall feel if flies to the deep in the sky? Where else living creatures are to be found? So, these are the questions that come in the curious mind. The envelope of gas and dust particles that surrounds the various celestial bodies is called the atmosphere, and the void region that extends beyond the atmosphere of celestial bodies is generally known as the space. Together, these celestial bodies, their atmosphere and the space constitutes our universe. The size of our universe is unimaginable to common human thinking. In the words of Sir Arthur Eddington, the universe is not only stranger than we imagine, it is stranger than we can imagine. When we look at the scheme of things across a scale, we come across a very striking similarity. In an atom, all protons, neutrons and electrons together occupy only a tiny fraction of it. Likewise, various celestial entities like stars, planets, their satellites and asteroids, together they form only a very minuscule part of the universe. That is, it can be said that they are scattered here and there in the vast emptiness of the universe. Many things are still being speculated about the universe, but it is important to intimate ourselves with our known universe in light of scientific evidences that we have been able to gather so far. The learning objectives of today's session is to know the definition of space, atmosphere and universe, to know how the space and atmosphere came into being in the universe, to know about the various constituents of the universe, to know about the properties and events that are taking place in the space, and to know the features of atmosphere in the earth and other celestial entities. Let us begin with the origin of the universe, its space and atmosphere. With instruments launched in the space like Hubble Space Telescope, International Space Stations, satellite like WMAP, COBE, many mysteries of the universe have been solved. At present, our universe is as big as the distance that light can travel in 13.7 billion years. However, at the beginning, the universe in entirety was confined within a very tiny dot. You can call it the ancient primordial matter. Possibly all the matter was in the form of pure energy in that tiny dot, producing unimaginable amount of heat due to the effect of enormous compression. Then a destabilizing moment occurs about 13.7 billion years ago, that is called Big Bang. That is a sudden explosion of space, although there was no noise because at that time there was no air to carry the sound waves. Following the Big Bang, various entities of the universe like planets and stars started taking their shapes. Formation of such entities and their evolution is a continuous process. Entities of the universe are like nebula, galaxy, protostar, star, binary stars, protoplanetary disk, planet, their natural satellites, asteroids, etc. A star is born as a gigantic ball of very hot, dense gas. With time, most stars develop their own planetary system except the binary stars. In this planetary system, there is a central star and planets along with their satellites revolve around it. Such an arrangement conserves the angular momentum, which is one of the basic laws of physics. Another law of physics which is omnipresent all across the universe is the law of gravity. Due to their immense mass, celestial entities attract the gases and space dust in their neighborhood and keep them attached while rotating themselves. This envelope is the atmosphere. The primordial elements of the universe were hydrogen and helium. Inside the core of first generation stars, which is like a nuclear furnace, these lighter elements fuse together to give rise heavier elements like carbon, oxygen, nitrogen, which are the essential requirement for life. Our universe is continuously expanding and the intergalactic void spaces for most of the galaxies are also increasing. Now, let us discuss some characteristics of the deep space environment. First is vacuum. Outer space is the closest approximation of a perfect vacuum. It is not completely empty, but contains a low density of particles, predominantly hydrogen plasma and helium, as well as some electromagnetic radiation, magnetic fields, neutrinos and dust. Even in the deep vacuum of intergalactic space, you can find still few hydrogen atoms per cubic meter. Practically, Deep space environment offers no effective friction, thus allowing stars or planets to move freely along the ideal gravitational trajectories. Next property is dark matter and dark energy. Universe is made up of only 4% of ordinary matter. Ordinary matter means the substance that we can see or touch and measure. The rest 96% is dark matter and dark energy. Also we can call it vacuum energy of space. This energy we cannot see or touch. The concept of dark matter and dark energy has not been understood well by the scientific community. The next important property is microgravity. As one moves away from any planetary body, the force of gravity gradually weakens. Deep inside space environment, gravity becomes negligible, although a state of zero gravity, that is perfect weightlessness, that never probably happens. Such condition is termed as microgravity, that is 1/1,000,000th of 1 g, where g is the acceleration due to gravity. Next important property is hazardous radiation. The presence of high level of UV and cosmic radiation, which are very injurious to living beings, that are present in the space. If we compare in space and Earth atmosphere has a protective shield of ozone layer and magnetic field, hence such hazardous radiation do not penetrate in appreciable amount in the Earth's atmosphere. But if we compare the atmosphere of Mars and Moon, because of thinner atmosphere and due to absence of such protective layer, presence of cosmic radiation is high in their atmosphere. Let us discuss the various entities of the universe. Let us start with galaxy. A galaxy is an assembly of vast number of stars, gas, dust along with some other exotic matter, all held together by the force of gravity. Stars of various ages can be found inside a galaxy. Generally, the central stars of a galaxy are older and appear more yellow, whereas those at periphery are younger, those are more active and appear blue. All the stars in any galaxy orbit the galactic center. So far about 125 billion galaxies have been identified. However, the actual number could be far more. About 80% of the identified galaxies are elliptical in shape, rest are either spiral or irregular shaped. Elliptical galaxies are older, smaller, less bright and less active. They houses more number of aged stars. On the other hand, spiral galaxies appear to be the busiest and brightest, and each may contain as high as 100 to 400 billion number of stars. In this photograph, there is a comparison of structure of a cyclone which appears in the Earth's atmosphere and a galaxy which appears in the space. In both the figures, in the galaxy there is a central bulge of mass, whereas in case of cyclone, the center looks void and surrounded by a white mass of clouds. But one similarity is that both the entity, the central portion attracts the surrounding objects. The second entity is star. Let us see how the star forms. At the beginning, there are patches of whirlwind cloud in space consisting of gas and dust. Gravity pulls them on itself, forming larger balls at the center of each cloud. These are termed as protostar. With time, a protostar converts into a star. Heavier stars shrink faster and burn quicker. Our sun took about 30 million years to burn. Now, let us see how the stars remain stable and how their decay begins. A star remains stable so long as the force of contraction and that of expansion are in balance. When most of the hydrogen gets converted into helium, the force of gravity dominates and the star starts sinking. Before its death, carbon or even heavier elements are formed in stages depending on the mass of the star. If the mass is high, then more heavier elements like iron could be formed. During this dying phase, the outer layer expands while the core contracts, with the result that the star appears much bigger, maybe about 100 times bigger and brighter, and also its color shifts from yellow towards red. Hence, in this phase, the stars are called red giant. The figure in this slide explains the entire life cycle of stars. From the gas and dust clouds, stars of various sizes are produced. Stars having size like that of a sun or smaller dies after converting into red giant. The outer cells of a red giant are ultimately detached from them and form planetary nebula, which are the precursor to new star and solar systems. The core becomes white, then we call it dwarf star. With time, the dwarf star loses its heat and light, and over billion of years it becomes a cold black mass, which is also called as black dwarf. Big stars die faster. They first form red supergiants, which is actually a helium core surrounded by expanding shell of gas. This is followed by formation of heavier elements at its core through nuclear fission. Iron is produced at the core when temperature of the core exceeds 5 billion degrees. The iron core crashes to a size as low as 10 to 20 km in diameter. The core finally vanquishes in a fraction of a second with huge explosions that can be seen from many light years away. This phenomenon is called supernova. It is possible that at any given instance, about 100 such supernovae are happening in the universe. A star that is 8 to 25 times bigger than the Sun dies as a supernova with its iron core so compacted by gravity that all its atoms are crushed into one super dense mass of neutrons. Hence, at that point, it is called neutron star. Neutron stars rotate at a very high speed, producing radio waves that sweep through the space like a lighthouse beacon. The neutron star, whose rotating beam can be observed from Earth as regular pulsed radio signal, are called as pulsars. Surface temperature of hottest stars can be about 40,000 degrees centigrade or even higher, whereas the coolest ones having temperature as low as 2500 degrees centigrade, and they appear reddish. Yellow stars like Sun lies in between these two extremes, like Sun's surface temperature is about 6000 degrees centigrade. Next is a black hole. Black hole is created when a star at least 25 times bigger than Sun dies. Because of the initial mass of the star, the gravity is so strong that the entire mass of the core instantly shrinks into a space that is in fact smaller than the nucleus of a single atom. It is said that even light cannot pass through a black hole. You know, light is the fastest moving entity of the universe. Since light cannot escape it, no other things will escape the black hole, and that is why it is called black hole. Next entity is called quasar. A quasar is a compact accretion region of a massive black hole. Stars, planets, or any other matter that happen to be in the neighborhood of a black hole are dragged into the vortex, then starts spinning around it and form the accretion disk, which becomes so hot that it radiates light before, and then ultimately those things are swallowed up in the quasar. Quasars are among the oldest and most distant objects in the universe. The light produced by a quasar can be trillion times brighter than that of our Sun. Such light is visible even from a distance of about 10 million light years away, that is almost the far end of the universe. Now, the very important is solar family. Sun is the central star of the solar family. It is a bright star. It burns about 600 million tons of hydrogen per second. Its current age is 4.6 billion years, and the nuclear reserve, nuclear fuel, that is hydrogen, is in such a quantity that it can survive for another 5 billion years. The 4 number of planets which are near to the Sun are called inner planets. These are Mercury, Venus, Earth and Mars. The rest are gas giants. There is an asteroid belt in between the orbits of Mars and Jupiter, and there is a Kuiper belt and Oort cloud at the outermost coast of the solar system. From the asteroid belt, meteoroids are generated and the comets are originated from the Kuiper belt and Oort cloud. Now, let us see how the atmosphere is in different planets of the solar system. Let us begin with Mercury. Mercury has a very feeble and highly variable atmosphere where pressure becomes as low as 10 to the power minus 14 bar. Its atmosphere contains hydrogen, helium, oxygen, sodium, calcium, potassium and water vapor. Because the planet is very near to the Sun, radiation and wind coming from the Sun exert a strong influence on it. Solar light pushes neutral atoms away from the Mercury, creating a comet-like tail behind it, whose main constituent is sodium. During the daytime, temperature reaches as high as 450 degrees centigrade, whereas at night time it becomes as cool as minus 170 degrees centigrade. The next planet is Venus. It is the hottest, means its atmosphere is hottest and temperature as high as 482 degrees centigrade has been recorded. Although Venus is not the nearest to the Sun, but why its atmosphere is so hot? because its atmosphere is a smoky mixture of carbon dioxide and thick clouds suffused with deadly sulfuric acid. Hurricane velocity winds exceeding 300 km per hour drives the acid cloud around the planet. Venusian sky is filled with thunder and lightning almost all the time, although rain never happens here. The atmospheric pressure on the surface is about 90 times higher than that of the Earth. Next, our planet Earth. So far we know Earth is the only planet which supports life. Various natural factors causes changes in the Earth atmosphere, and in the past has brought warm phases and cold phases in cycle. In recent times, due to anthropogenic activities, there is a build-up of greenhouse gases in the Earth's atmosphere. That is why we are facing issues like global warming, climate change, etc. In its early days, Earth had higher temperature even that of today's Venus. The primeval atmosphere on Earth comprised of nitrogen, carbon dioxide, carbon monoxide, water vapor, some methane and ammonia. At present, almost 99% of the Earth's atmosphere is composed mainly of nitrogen and oxygen. Rest are inert gases, carbon dioxide and some highly variable content of water vapor. Earth's atmosphere shows a distinct vertical temperature profile. Next comes Mars. The temperature on Mars does not exceed the freezing point even during summer. It has a thin atmosphere. Storms of red dust whipped by strong Martian winds rage across its surface frequently. Evidence has indicated there is a possibility of life in Mars. Frozen water can be seen in its poles, and also there are evidences of channel-like features, which is the evidence that once maybe there have been free-flowing water. Much of the water probably has now vaporized because it has a thin atmosphere. Next planet of the solar system is Jupiter. It is a gas giant and the atmosphere is quite stormy. There is a distinctly identifiable storm zone on Jupiter, which is known as Great Red Spot. This is actually a permanent turbulent system about 8 km high, and its width is about 3 times than that of the Earth. Thunderclouds and jack bolts of lightning shake and sear Jupiter's atmosphere all the time. Unlike in Earth, the violent storms of Jupiter are possibly driven by the internal heat. Jupiter is surrounded by at least 3 rings that formed when dust from its nearest satellites was tossed up into the space. Next comes Saturn. Saturn is a bit less turbulent than Jupiter, but from time to time it experiences great storms which form the color bands in the atmosphere. Billions of ice particles mixed with rocks and silicates whose size may be like a sand grain or as big as 1 meter in diameter. Those particles encircle and orbit the planet and appear as some prominent rings of various width. Then comes Uranus. Uranus is a gas giant with a rocky core. The fastest wind speeds on Uranus was recorded as high as 700 km per hour. Its atmosphere is rich in methane. Sunlight scattered from the clouds surrounding Uranus is reflected back through these methane layers. Hence, the atmosphere appears as blue-green. The temperature at the top of Uranus's icy methane cloud is about minus 215 degrees centigrade. Then let us talk about Pluto. Earlier Pluto was considered as a planet like any other planets, but as per the new definition of planets, now Pluto is designated as a dwarf planet, and there are chances that there are many Pluto-like dwarf planets in the solar family. Because of its huge distance from the Sun, only very little sunlight reaches Pluto, and indirect evidences suggest that Pluto has an atmosphere and that the planet may be like a frozen snowball of gas and dust. Now let us discuss the atmosphere on Earth's moon. The density of atmosphere in the moon's surface is comparable to that of the outermost fringes of Earth's atmosphere. For practical purposes, it can be considered as a vacuum. The pressure in the lunar atmosphere is only around 3 into 10 to the minus 15 atmosphere, and that pressure also varies throughout the day. Because of the absence of a real atmosphere, moon cannot absorb appreciable quantities of radiation and does not appear layered or self-circulating. Due to low gravity condition, gases are lost to space at a high rate and require continuous replenishment. One typical feature of Moon's atmosphere is the presence of sodium and potassium gases. Now, let us discuss the significance of Earth's atmosphere. What is unique in this atmosphere? The Earth's atmosphere absorbs harmful UV radiation and allow passage of important visible radiation, which is important for plant growth. It prevents excessive heating during the daytime and also excessive cooling during night time. It contains nitrogen, oxygen, carbon dioxide gases that are essential for plant growth. It protects the surface of the earth and all living creatures on the earth from the direct impact of meteorites, because once the meteorites enters the earth's atmosphere, they get burnt up due to the friction of the atmosphere. It serves as an integral part of the biogeochemical cycles of nutrient elements like carbon, nitrogen, oxygen, etc. It helps in the flow of energy in water vapor through dynamic processes of air flow. The atmosphere helps in radio communication, it helps in the movement of aircrafts, and it helps in the dissipation and dispersion of pollutants. To summarize, the universe is about 13.7 billion years old. It is as big as the distance that light can travel in 13.7 billion years. Furthermore, it is expanding continuously with time. Like in an atom, only a tiny fraction of the universe is made up of matter, the rest is void. Outer or deep space region is like a perfect vacuum. Dark matter and dark energy, hazardous cosmic radiation, and microgravity are some important features of deep space. The primordial atomic elements of the universe were hydrogen and helium. The heavier elements like carbon, nitrogen, and iron were formed through nuclear fission at the core of the stars. Mercury, Venus, Earth, and Mars, these are the inner planets, and they have relatively thinner atmosphere compared to outer planets like Jupiter, Saturn, Uranus, and Neptune.